So you have dx, the integration of ux times u is equal to the integrating factor ux times qx. How we got here? Since the integrating factor ux is the exponential of px dx. If you take the derivative over x of this ux times y, you will get y prime times the integrating factor plus the derivative of the integrating factor times a function y. And now we compute this y prime. Y prime of x is equal to exponential the integrating factor px dx times the derivative of this part which is simply px. So when you substitute this here, what you get? You will get u prime times ux. This is actually ux times px. So you will get u prime times ux plus ux times px times u, and this actually equals to this part which is ux times qx. Now it is very clear that you could simplify and divide by this integrating factor. And also the integrating factor is never equal to 0 because it is the exponential of the integral of px dx. So the exponential is never equal to 0. And when you divide by this integrating factor, you return back to your equation y prime py is equal to q. So now we are going to solve the first, this is the first method. Now I will give you the method that we have seen in the lecture. So first order linear equation. We have seen that a linear equation, we have the following linear equation, which is dy over dx plus p of x times y equals qx. So this is equation number 22. P and Q are given continuous functions. Next, what we did is we considered a change of variable So we will search for a solution in the form of the product of two functions, that is, u is equal to a function ux times another function v of x. Okay? When you substitute this into by substitution, in the equation 22, you will get So the derivative of u prime, what is the derivative of this guy? It is simply u times dv over dx plus the function v times du over dx plus p times y, which is u times v, and all of this is equal to the function q. All of those functions are depends on the variable x, and we didn't write them to simplify the formula. So now we continue. As you can see, we have here u and you have here u, so you can factor this out to get u times dv over dx plus p times a function v. This what is left is v times du over dx. This is equal to q.